I'm Vatsal, and I'm working as electrical and electronics engineer profession in electric vehicle company. And I'm going to present today insight to the control of battery electric vehicle and the opportunity for mechanical engineering graduates with this emerging technology. So let me start with a story which is related with electrical engineering and mechanical engineering. So Mr. Shashank graduated in 2005 with a bachelor in electrical engineering with his 10 years of experience in the design of AC induction motor drives at Denfos. He is now expert in water pump technology as well. So basically he is designing the induction motor drives for pumps, and he is now able to better communicate and convert the client requirements to the drive design inputs. So this is typically how what his working environment looks like. So he will be designing mostly this motor drives, but this will be driving the pumps, and these pumps will be again used in some industrial process. So another example is Mr. Anil, who is working since long with Bharat Heavy Electrical Limited. And based on his reach experience for the traction motor manufacturing, whether it's AC motor or DC motor, he can now easily correlate electrical design data with the CAD drawing. So the point I'm trying to make is for an industry, an engineer is an engineer. It's yes, there are different branches, but altogether for any typical engineering project, they all engineers work together. So this electrical and mechanical engineering can be considered like brothers. These are twin brothers, and they are empowering each other. One gives energy to another, and another gives it back to the first one. So this is, let's say, electrical guy. This one is a mechanical guy, and the energy flows from electrical to mechanical as a motor, or from mechanical to electrical as a generator. So there is a very strong bonding between these two brothers, and yes, they are a member of the same family. So the seesaw picture actually reflects how the energy is transferring from one to another. And yes, you have already gone through some of the analogies like spring, mass, and damper. The three basic elements of mechanical engineering can be easily correlated with the resistance, capacitance, and inductance. And even the energy equations for electrical systems and mechanical systems are having the same format. So this particular analogy will help you to understand how electrical and mechanical goes together. So all these engineering projects are actually interdisciplinary, and typically electric vehicle systems are a combination of power electronics, embedded systems, which is again microcontroller programming and electronics, and the chemical engineering for the battery, and we have vehicle dynamics, control systems, and thermal management and communication. So electric vehicle technology is interdisciplinary in nature. Yes, automobiles are there since years, and the opportunities exist for mechanical engineers. But now, electrical and electronics and computer engineers also will get opportunities to enter into this market. So before we start, I would like to tell you all that this is an electrical engineer's quick viewpoint. So I'm going to present a very quick viewpoint. So this particular session can be very well elaborated in 40 to 45 hours. So this particular contents are compressed, considering that this is just an introduction or short summary of electric vehicle program. So I will be trying to give you the analogy examples for your better understanding, where you can correlate electrical things with mechanical things. The mechanical perspective, I would say, is not in detail. It's kind of a glassboard type of perspective. I will be presenting the bird's eye view. This is not a detailed description of electric vehicle technology. So I'm just going to run through what is an electric vehicle technology and how the control systems or how mechanical engineers can play an important role. So the control equations are implemented electronically. So here, let's say this is a mechanical perspective. Here in the picture, you can see the glass board where on a beautiful seashore, you can see the coral reef within the boat. The electrical perspective is the deep dive, uh, where you take the oxygen cylinder and get into the sea actually. So I'm going to present today what is called a glass boat kind of an ride for mechanical engineering students. So this just for an understanding that what kind of details or what kind of information you can find in my presentation. So going ahead, an automotive application, what is the current market and what is the future that I will be presenting in this slide. So conventional vehicles are IC engine type, and this particular vehicles requires a battery for starting the engine and run the auxiliary items like the car infotainment systems or light bulbs and indicators and etc. This particular battery was intended to give the required cranking amperes. So when you just provide the crank or ignition to your car, you are actually making a short circuit with the battery and the heavy amperes are drawn. And that runs your engine and it gets started. So normally these batteries are of low voltage type and lead acid in material. The lead acid also comes with different materials like flooded battery or gel battery or absorbent glass material type of batteries. How these batteries will get charged? The alternator, engine driven alternator, or we usually call it as the starter generator. So this particular starter generator will be keeping the battery charged. The next paradigm shift, considering the hybrid and electric vehicle, is just because of the evolution in the battery technology. So now, just earlier and now, the battery is used for only starting, but in the recent future, you will see the cars on road where the batteries are actually running the entire vehicle. So battery is the energy source for the propulsion. Normally, these batteries are of high capacity and lithium ion type. These batteries are intended to be charged from a power grid or a power supply, and or it may get charged from an engine. This particular hybrid or electric vehicle batteries are high capacity and they are not the 12 volt VRLA type battery. They are of around 300 to 400 volt and very high capacity. That depends on the speed and range of the vehicle. So the battery has changed from the automotive applications from IC engine type of vehicle to hybrid and electric vehicles. So yes, this batteries comes with their own pros and cons. There has to be a very safe environment and these batteries must be handled with care. So considering this automotive application, if you consider this aerospace and marine related applications, the automotive varies from a very, very small bicycle or a robot to the big truck or bus. So there are varieties of applications for the automotive. So automotive is quite a big market for electric and electronic kind of technology. Yes, there are special vehicles also coming up with powered by batteries. These are forklift or wheelchair or drones and some special robots. So this is an transformation from one type of vehicle technology to another type of vehicle technology. So now I wish to present you a block diagram where you can consider how what are the components of an electric vehicle system. So electric vehicle is a system of systems. This particular block diagram is a generalized block diagram for a motor drive system, where you can see there is an electric motor and there is a power supply. This can be considered as a battery. There is a power converter, which is controlling the power from battery to the motor. and here we have a mechanical load. So this particular mechanical load, where you can see this particular mechanical load, this is the fundamental aspect when we start any particular design. So from the load perspective, an electric vehicle is open to any type of load, right? So that depends on how you are going to drive. So this particular block diagram is going to take you into the better understanding of what happens when an electric vehicle is going to run. So here, for example, you have a throttle command, or you have an accelerator from the driver's cabinet. This can be a torque command or speed or position command. This goes to a controller, and based on the actual value of the motor and the load system, and the set value and the actual value, that will form an error, and this particular error goes to a controller similar to a PI controller or like that, and this closed loop control will ensure that whatever is a set point by the driver, that is achieved by the motor and load system. So any typical electric vehicle design system will start with the load actually. So the design process is like this. So you consider the load aspect. Based on the load, when you have better understood your load requirements, then it goes to the motor design. So based on the motor selection and the motor type, then you design a power converter, and based on your range expectation and the top speed and other things, you decide about the type of the battery and capacity of the battery. So as an engineer, we start with very basic questions, which are like, which is based on the power calculation and speed and torque calculation. So how much is the torque in, let's say, Newton meter for 8 bhp engine at 7500 RPM. So this is a typical example of the maximum power from an Activa engine. So this is the basic activity where you start your basic calculations. So you calculate torque from speed and power, or you calculate speed from the torque and power, and vice versa, like that. Similar question can be what should be the RPM of a motor where it has to run the vehicle at 80 km/h speed, and the wheel diameter is 17 each. So you can apply the basic equations for transforming this linear velocity and angular velocity. So from this angular velocity, or this linear velocity of 80 km/h, you can calculate how much should be the RPM of the motor. And now based on that, you have to select how much is my maximum RPM, and at this RPM, will the motor be able to provide the enough required torque. So this is the block diagram of a motor drive system. Going ahead with better understanding of the mechanical load. So how exactly you define a mechanical load on a vehicle? So this mechanical load on a vehicle is everything about a drive cycle or a driving pattern. So the basic consideration for mechanical modeling are the weight, how many passengers are sitting on a vehicle, whether you are considering a 3-wheel or 4-wheel, and how much is the total capacity, and weight of the vehicle and weight of the passenger, then the amount of acceleration you want, how much is the average speed of the vehicle, what is the gradient, up gradient or the gradability of the vehicle, how much is the air drag that is going to affect the vehicle, and what is the rolling resistance, and ultimately what is the pattern of your driving, right? Say in the morning you start with your two-wheeler, and when you just started, so you immediately raise up to the speed of 20 km/h, and then you are stopping at a crossroad, and then you again get the top speed of around 50, and then again there is a stop time. So this particular pattern of speed versus time is known as a drive cycle, and the area under the curve is going to give you the total distance traveled, and that basically corresponds to the amount of electrical energy used by a vehicle. So this is the very first step in the design of electric vehicles. So usually the mechanical engineer uh, team is going to model these parameters. Say if these are the parameters and this is the pattern in which we are driving, how much is the energy going to be expenditure? And at this speed, let's say at 90 kilometer per hour speed, and at this much of steep braking, what happens to the vehicle, and are we able to pass our test based on this Indian driving cycle? So this is typical Indian driving cycle where these vehicles are required to pass their test based on this particular uh, pattern, and all the mileage and efficiency and the battery range are predicted based on this standard driving conditions. Yes, definitely this doesn't reflect the actual driving condition, but this is how we mathematically model the requirement for motor capacity. So going next, which are the motors used for electric vehicle? So as I said, the design path is from understanding of the load to the motor and then to the battery. So first we will discuss the motor. Uh, the light electric vehicles are using, or the, let's say two-wheelers, the cycles and scooters are using the hub motors. The hub motors are actually in-wheel motor. So the motor is inside the wheel, and that is preferred for L1 or L2 kind of category of the vehicles, where the rotor is permanent magnet and this is surrounding the stator. So normally in most of the types of the motor, you will get the rotor inside the stator, right? Or the shaft is coming out. So here you will not find any shaft coming out of this motor. There are no shaft coupling and there is no power transmission required because this is in-wheel motor. So these motors are preferred for light electric vehicle application. Similarly, induction motors and other high power special motors are preferred for three-wheelers and four-wheelers and bus also. So three-wheelers and four-wheelers, yes, there is a power transmission requirement and there will be a fixed gear ratio, and it is always better to control the speed and torque of the motor instead of changing the gears. Some of the vehicles, some electric vehicles are preferring the gears, but most of this can be controlled directly by a motor controller with the speed torque requirement. So this is a typical image of the in-wheel motor from Bosch, and this typical motor is intended to be used in two-wheeler application. And if you open up this particular motor, this is another type of motor, but looks similar to this. So here you can see the windings. This is called the armature winding, which is inside of the arrangement. And these are the permanent magnets. And these permanent magnets are surrounding this stator. And there is very 1 mm or 2 mm air gap between the stator and rotor. So if you open up any bicycle motor or electric scooter motor, you will see something this kind of arrangement. So here there are no arrangement of the mechanical power transmission because whenever you give three-phase supply to this winding, this permanent magnets will get the force effect and they will rotate the entire wheel. So this is called in-wheel hub motors. So this is a typical technology where brushless DC motors are preferred. The permanent magnets gives an advantage of high torque to weight ratio because these motors are really low voltage considering the available voltage of the battery, and this has to be accommodated in a typical volume. So based on the available volume and the peak torque requirement by the motor, the permanent magnets are more preferred. So this is about the motors for electric vehicle. So you will see in arrangement where you see that Tesla Motors drivetrain, you will see the big induction motor, and that is driving the uh, entire vehicle at very high speed with a very good acceleration. So that type of motors are usually induction motors. Nowadays, Tesla is also shifting from induction motors to the permanent magnet motors, considering their advantages.